Hello guys, so this is a project what dialect law. So first of all, what's a dialect? And our focus is on English in general. So every region has a specific way of speaking English. They would use their own peculiarities in speaking the way in speaking English. Use certain words that are only specific to a region. So what we're trying to do here is to classify these dialects and then translate one dialect to another. The reason we're translating is so that people can understand the peculiarities from one dialect to another. So we selected 6 classes or 6 particular dialects as shown in the image, and we have 30 sentences for each of these, and we took 30 extra sentences for the formal case, just so for a baseline. So formal English is 30 extra sentences. These are some of the examples of the dialects sentences. So each of these have a peculiar word associated to that dialect, and this is what we're trying to classify, and this is what we want GPT-4 to classify.
Okay, so this is the general model. So in the context input, we'll be providing it, we're telling it what to do. So in this case, it's to classify, and depending on whether we're doing it, we're testing it on the few shot or the chain of thought, we'll provide it examples as well. In here, we'll also be limiting what classes it can classify into. In the input prompt, we'll be providing it the sentence that we want it to classify, and it will be providing us the output, which can be used for whichever other chatbot you want to use it to be tagged along to. Okay, so this is our accuracy. Clearly, it's not very good. The baseline we are comparing it to is the zero-shot classification. As you can see, it probably only got like 1 extra correct. So what went wrong? So not all sentences are actually like really part of a single dialect. So like some sentences can range from, can be a spectrum. So for example, the first sentence, let's have a wee chat over a cup of coffee. So this is actually recorded as Irish in our database, but when we dug a bit deeper, it's actually more Scottish, and GPT classified it as British, which is kind of fair. So for the sentences, there are also other sentences, which is really hard to tag a dialect to. So for this sentence, for example, it's tagged as Singlish in our database, but really you could kind of classify it as like any, because there's not really a lot of distinctive features in that one.
So in order to correct this, we added another label, an extra label for some of these sentences, not for all of them, just for certain sentences, like the first and second sentences. So the first one had a little bit of British, so we added British just so that because it did have a little British tinge to it. Whereas the second sentence, since it didn't have much of a Singlish vibe to it, but it is in our database Singlish, we took formal to give it as an extra label. But there are sentences which didn't have any extra label necessary, and we gave them straight up just one particular label. So after that, we reassessed the reprocessed data, and our accuracy level increased, but we still had a little issues, mostly because the issues were with Irish, British, and South African. These dialects often were misclassified because they're pretty close. As you can see in the image, they're very close to each other. And also, GPT-4 wasn't open to classifying them to any other dialect except for formal when it was very simple, and that was one more issue. And now that we're done with classification, we're moving on to translation, which is our second part of the project. So the model is similar to classification. It's just that we change the prompt here and we give the particular dialect we require. And then once we send the sentence over and we see the output, and we must assess this basically giving a mean opinion score. It's just that we give it a score from 1 to 5 and see how good it is.
Yeah, so as just explained, we'll be using a mean opinion score to judge how well our translation did. So for this case, we use 30 sentences of Indian dialect and Singlish dialect, mostly because Josh and I can properly assess them based on the rubrics, which is here as well. So the mean opinion score actually ranges from 1 to 5, and you'll get additional scores if it fulfills like the requirements in rubrics, with 5 being the best and 1 being like the worst score. So the main comparison that you're comparing against is the zero-shot, zero-temperature translator, which scored on average about a 3.9, and the model that we actually were tuning a lot more, spending a lot more time tuning, is the chain of thought one at a lower temperature, and it's got about an average of 4.3. Okay, a lot of them, but these are generally examples that come out from the translator. So in general, we felt the translator did well. And it managed to translate certain sentences in a very curious way as well. For the chain of thought, especially, it managed to translate sentences even without using dialect-specific vocabulary, and it just like tweaked the sentence structure so that it really sounded more like the dialect. However, there were issues where it would just use dialect-specific vocabulary, such as ya, only, la, and shiok, like way too much and way out of context. And like, so that was the main fault of the translator. Okay, so discussions. As mentioned previously, dialects really are very hard to classify as like a single thing. Really, like as you dug deeper, it really felt more like a spectrum. People can pick up dialects wherever, like from wherever they live, and it's best to classify them as like having like multiple potentially. But potentially as well is for future classification, maybe more of a spectrum. So you classify a sentence as like maybe 2/3 Irish, 1/3 British. And the last one is that we also noticed that certain dialects with like less speakers tend to perform a lot poorer. So our Irish, Singlish, and South African datasets performed a lot worse because there are just less speakers who speak these dialects. Okay, thank you so much.